Example 3, velocity of a falling ball. Suppose that a ball is dropped from the upper observation deck of the CN Tower 450 meters above the ground. So the first thing we need to do is to find the velocity both when t is equal to 5 and when the ball hits the ground. So it's efficient to start by finding the velocity at a general time t is equal to a, and we're going to be using the equation of motion s, which is equal to f of t, which is equal to 4.9 t squared. Now let's recall back in section 2.1, the distance in meters falling after t seconds is 4.9 t squared, which is how we get the equation of motion being the following. So now, since we're dealing with velocity, we're going to use the formula for the velocity, which is the limit as h is approaching 0 of f of a plus h minus f of a over h. So now from the equation of motion, we know that f of t is equal to 4.9 t squared. So for step number 3, we want to find the limit as h is approaching 0 of f of a plus h. So that means we're going to take the function 4.9 and then use the input of a plus h for t, and then we're going to square it, minus, again using the same function, 4.9, plugging in the value of a and then squaring it, divided by h. Okay, so now the next step we want to do is then to square that. So we have 4.9 times a squared plus 2ah plus h squared minus 4.9 a squared divided by h. So now let's distribute the 4.9. So we have the limit as h is approaching 0 of 4.9 a squared plus 9.8 ah plus 4.9 h squared minus 4.9 a squared over h. So now we can combine like terms, so we know we can say that 4.9a squared minus 4.9a squared is 0. So what do we have left in our numerator? Well, you can see here that if we look at what's left here, we can factor out an h. So if we factor out an h, what's left is 9.8a plus 4.9h divided by h. So we can simplify the h. So now we have the limit as h is approaching 0 of 9.8a plus 4.9h. So now if we evaluate this limit, then we have 9.8a plus 4.9 times 0, which gives us 9.8a. So what that does is, that tells us that the velocity at a up here, so the velocity at a is equal to 9.8a. So we were able to find the velocity at a to be 9.8a. So now what we want to do is we want to answer the following questions. It's saying, what is the velocity of the ball after 5 seconds? So that means that when t is equal to 5, then what is the velocity? So we just need to plug in v of t, or in this case, v of 5, and that's 9.8 times 5. And so 9.8 times 5 gives us 49 meters per second. And so therefore, the velocity after 5 seconds is 49 meters per second. Now in part B, we want to be able to find how fast is the ball traveling when it hits the ground. So, since the observation deck is 450 meters above ground, the ball will hit the ground at time t subscript 1 when s of t subscript 1 is equal to 450. And that is 4.9 t subscript 1 squared, and that is equal to 450. So now what we want to do is we want to then divide both sides by 4.9, so we get t subscript 1 squared, which is equal to 450 divided by 4.9. And then taking the square root of both sides, we only want a positive number. So we have the square root of 450 divided by 4.9, which gives us approximately 9.6 seconds. So now we can then find that the velocity of the ball as it hits the ground is therefore, using the velocity formula that we found at the beginning, we can say that the velocity at t1 is going to equal 9.8 times t1. So therefore, if we take 9.8, multiply it by 9.6, then we get 94 meters per second. When